Okay, so last one of these proofs for now. And now we're talking about rectangles. I'm trying to prove rectangles. So if we think about, once again, our different subsets of parallelograms, we have the rhombuses, which a rhombus is a parallelogram with sides that are the same length. And a rectangle is a parallelogram with congruent angles. And for them to all be the same, they would have to be 90 degrees. So all of my angles in a rectangle are going to be 90 degrees. So my given statement is that I have EFGH and that it's a parallelogram. And then I know that line segment EG is congruent to line segment HF. So my two diagonals are congruent. Okay, that's going to be very important for this entire proof and for our final statement. So we start off with our given. So I have two givens here. I have EFGH is a parallelogram. That's been given to me. And I've also been given that line segment EG is congruent to line segment HF, and that has also been given. Okay, so I don't really want to draw this statement on my picture. That would look a little bit confusing. So for right now, we're just going to remember that they are congruent. So my first thing that I'm going to come up with here is that line segment EF is congruent to line segment GH. So I have EF is congruent to GH. And if we remember, one of our very first statements that we proved throughout these videos is that if a quadrilateral is a parallelogram, then the opposite sides are congruent. Okay, and it is a parallelogram, so the opposite sides will be congruent. So I can say opposite sides of parallelograms are congruent. Okay, so now I'll draw those lines. And then I can also say that line segment EH is congruent to line segment EH, and a line is obviously equal to itself, and that is reflexive. Now you really have to have an idea of what you're really talking about here and what you're trying to go for. And so obviously through all these proofs, we've been using our triangular proofs. And so right now I'm looking at a triangle here. So triangle GEH and then triangle FEH. I'm really trying to work with those two statements. Okay. And since I've been given that line segment, I'll just draw a line here, that this line, this diagonal, is congruent to that diagonal. I really have a side, side, and another side, and a side, side, and another side. So I can prove that triangle EFH is congruent to triangle HGE or GHE by side, side, side. You kind of have to visualize what sort of triangles you're trying to figure out, how you're going about this process. Even before you start, you need to have a game plan before you get going, so we're not doing useless steps that just take up time. You be as concise as possible. Okay, so now I can say that angle FEH is congruent to angle GHE. So angle FEH is congruent to angle GHE. So I have this angle right there is going to be congruent to this angle. And if you think about it, that's sort of the bottom corner of my two distinct triangles. I have this triangle there, so it's the bottom corner. I have this triangle there, that's that bottom corner. Okay, and so I'm going to say that those are congruent because of my CPCTC, or congruent parts of congruent triangles are congruent. I can take this triangle, cut it out, flip it over, put it on top of this triangle, and it'd be exact same. It's a copy. They're congruent. So that means those two same corners are going to be the same angle. Okay. Now, I'm also going to say that angle FEH and angle GHE are supplementary. Now, I think this might be a new reason statement, and that new reason is that congruent supplementary or consecutive angles of a parallelogram are supplementary. So if I look at any of my previous proofs, if I look at this one, I have this obtuse and an acute angle. If I add those together, it's going to equal 180 degrees. Think about a square. If you add two consecutive corners, it's going to be 180. If I look at my rhombus here, add those two consecutive angles together, it's going to give me 180. Okay, so my reasoning behind this statement of those two being supplementary is that consecutive angles of a parallelogram are supplementary. So that's a new one that we need to really remember. That's very important. So consecutive angles in a parallelogram, they are supplementary, which means they're going to add up to 180 degrees. Okay, now I know that these two angles are the same, and we've already done a step of this proof, and let's see if I can find it here. It's really long. Okay, over here. So I had that my two angles were supplementary, and so I did some substitution, I did some addition, and then some algebra to prove that it was a right angle. Okay, so instead of doing all of that, I've already proven it at that one proof, but now I can also, I'm going to write that the measure of angle FEH equals 90 degrees because congruent, that means they're the same, remember? So same angles that are supplementary, so congruent supplementary angles are right angles. So since they're the same and add together, they equal to 180. They obviously equal 90 degrees each. Okay, and so then my final step of this proof is my proof statement, which is EFGH is a rectangle. Okay, and I can prove that because if this is a 90-degree angle, okay, well, GHE is the same. And if I keep going around, that means that this has to be 90, that has to be 90. If one of them is 90, then they're all going to be 90. Okay, and remember the definition of a rectangle is that it's a parallelogram with 90-degree angles. So since one of them is a 90-degree angle, it is a parallelogram. It's a rectangle because of the definition of a rectangle. Now, my main point for this proof really is going back to what I was given to begin with, and it's that diagonals of rectangles are congruent. Okay, so it's a rectangle. My diagonals were congruent. Now, these were 6 new proofs that are really important for us to be able to solve some algebraic problems that will come into play here soon, and as well as just giving us more reasons to put behind statements for further proofs. And if we think about our sort of subsets and sets of quadrilaterals, we really need to figure out what applies to which. So if you think about all of my parallelogram proofs, the first 3 that we did, well, a rectangle and a rhombus are both a parallelogram. So I can use all those parallelogram proofs for my rhombus and my rectangle. Okay, if you think about a square, if you think about a square is a parallelogram because it has right angles. So I can use this rectangular proof on a square. Okay, if you think about a rhombus has all sides that are the same. And so a square is also a rhombus. So I can use my rhombus proof on a square. So you need to be able to think about, okay, well, this doesn't just apply to a rhombus. Okay, it also applies to a square because a square is a rhombus, or a rectangle relates to a square, or these parallelogram proofs apply to my rectangle as well as my rhombus. Okay, so we need to be able to pick and choose what relates to what and be able to use those statements and reasonings to help us prove other statements and other future proof problems.